Okay, this week we will start a new chapter. Chapter is multistage amplifier. Okay, this is what we have learned in chapter 3 and chapter 4. In chapter 3, we have discussed on the analysis of the BJT amplifier circuit. And then for the chapter 4, we are using the MOSFET instead of BJT. We are using MOSFET for the amplifier circuit. Both of the amplifier circuit consist only one transistor for chapter 3 and chapter 4. This is what we call a single stage. The single stage here refer to the amplifier circuit that consists only one transistor. So in the both chapter, we have discussed several parts or several subtopics. So the first is we have discussed on the DC analysis. Okay. And then we also have discussed on the AC. So this is the AC. The AC analysis cover the middle frequency. So in the middle frequency, what we analyze is the input impedance, output impedance, and the gain. Okay, and then we move to the analysis of the frequency response. The objective was to estimate or to predict the dominant cutoff frequency at low and high frequency region. So we have the low frequency cutoff frequency, and we also have the high cutoff frequency. Okay, so in this chapter, this is the multistage. Multistage is the combination of multiple amplifier. Okay, it can be the combination of 2 or it can be 3. So it is a combination of more than one amplifier. So since we have covered the BJT and amplifier circuit, so you can expect this we expect the student to be able to analyze the multi-stage amplifier that made up from the different type of amplifier. Okay, so for example, the BJT itself has the it has the 3 configuration. We have the common emitter. Okay, and we also have common base and common collector. So, and then for the MOSFET, okay, for the MOSFET, we only cover the E-MOSFET, the N-channel E-MOSFET. But for N-channel E-MOSFET, it also has 3 configuration, which is this is a common source, and we have the common gate, and last one is the common drain. Okay, so the combination of the combination that consists in the multi-stage amplifier can be from this 6 configuration. So it can be the combination of BJT common emitter plus BJT common base, or BJT common base plus common collector, or even BJT combined with the MOSFET. So you can expect many type of combination. So please bear in mind that for this type of topic, so you need to be able to understand the basic concept. So because we have many variation, so memorizing the equation will not be an effective approach for this chapter. Okay, so before we move to the explanation, the introduction of multistage, so I want to discuss, or I want to do some revision. What is the ideal amplifier? So the amplifier itself can be divided into several categories in terms of the signal, the input signal, and the output signal. For example, we have the voltage amplifier. The voltage amplifier amplify the input voltage to the output voltage. So, and then we have the current amplifier amplify the input current become the output current. Okay, and then we also have other two type of amplifier, which is transconductors and transresistor. So for this slide, just want to recall back the criteria for the voltage amplifier and current amplifier. Okay, for the voltage amplifier, ideally we want to have the very high input impedance. So very high input impedance. So ideally this is infinity. So why we want to have the very high input impedance? So the input impedance in a general model of amplifier. So this is the ZI. This is the input port. So the voltage that is inserted into the amplifier is the voltage across the input impedance. So the voltage across the input impedance will become the input voltage of the amplifier. So at the actual application, the input will be connected to the source, and the source will have the internal resistance. So sometimes it's denoted as the R signal. So this is the V signal. So we apply the V signal to the amplifier, but the actual voltage at the VI here will be the voltage division between the ZI and R signal. So we the best condition is when the ZI is far more high value or bigger value than the R signal. So if the ZI is infinity, almost all the V signal will become the VI. So this is why we need to have the high input impedance for voltage amplifier. And then for the at the output impedance, okay, at the output side of the voltage amplifier general model, so this is AVOC VI. Okay. The amplified signal, this is the Z out, and this is connected to the load. Okay. So the generated signal, ideally we want to make the all the generated signal is drop in the across the load. So we have here the voltage at the load will be the voltage division between the Z out and between Z out and the load. So because we want all the AVOC VI is dropped across the load, so Z out ideally we want to have a zero value. So when Z out 0 means that all the AVOC VI is dropped across the load. So this is the ideal output impedance. And then in terms of the gain, we want to have a very high gain, so we can amplify very small signal. Okay, this is the general model for the voltage amplifier. Okay, how about the current amplifier? If you want to use, if you want to design a current amplifier, so you need to bear in mind the input impedance need to be low. So ideally is 0 input impedance. Why? Because for the current amplifier, when the input impedance is high, it will decrease the actual current inserted into the amplifier. And then for the output impedance, the value need to be very high, ideally need to be infinity, so that all the generated output current is will flow to to the load. So this is okay. Since we for the chapter 2 we only consider the voltage amplifier model, so I'm not going to discuss about the current amplifier model in detail, but if I sketch the current amplifier model, so this is your Z out and this will become your load, and this is the your generated current dependent, sorry, voltage or current dependent, sorry, current dependent current source. So this is the generated, the I will be divided into the Z out and load. For the current amplifier, we want to have the very high Z out, so that all the generated current will flow across the load. Okay, so this is the current amplifier. Okay, so this is the requirement, the criteria for the ideal voltage and current amplifier. Okay, next let's compare with the actual actual circuit that we have discussed. We have the configuration. For example, we consider the BJT amplifier. We have the common emitter, we have common collector and common base. Okay, in terms of the input impedance, for the voltage amplifier, okay, for voltage amplifier, common collector is good. Okay, voltage amplifier. Let's say I put here the voltage amplifier is good. Okay, for the current amplifier, common base is suitable. Okay, and then if you see the common collector, is also good in terms of the output impedance. Is also a very good circuit design for the voltage amplifier, because the output impedance is low. However, the voltage gain is less than 1. Okay, so this is less than 1, so this is no good. Okay, the same goes with the common base. Although the impedance, input and output impedance is very good, however the current gain is not good. Okay, so this means that for every configuration, it has the good side and it has the not so good side. So when you design the amplifier, you need to trade off between a certain requirement with a certain requirement. Okay, because we have the input impedance, output impedance, and the gain. So sometimes we compensate the gain with the input impedance and output impedance. Okay, so the question, which configuration is suitable for voltage and current amplifier? The answer is quite difficult, because it depends on your requirement and it depends on your resources, whether you have certain others requirement. So this is quite difficult question, but however, when you want to design something, you will come to a case where you need to combine the amplifier configuration. For example, because you see that the common base has a very large gain, so common base is very large gain, and the output impedance, but the impedance wise is not very good, so you may want to combine the common collector and common base. You combine the common collector and common base for voltage amplifier. So the common collector will provide you a better impedance matching, and the common base will provide you a better amplification voltage gain. So this is the objective or the motivation or the reason why we need to have a multi-stage amplifier. Okay, and then another reason is in terms of the gain, is simply because of the gain. We want to have very high in case of the situation where we need to have a very high gain. So maybe single stage is not enough. You need to have a multiple stage. So you have the multiplication effect. So you have, at the end you will have the very high voltage gain.